All right, so we've seen how to look at angles and triangles, but in order to look at angles that don't fit in triangles, say angles bigger than 90 or bigger than 180 degrees, we need a better way to represent angles. So we're going to be looking at how to represent angles on the Cartesian plane. So there's some rules we need to follow when we're doing that. Some just conventions to keep ourselves consistent. So one of the rules is that positive angles start at the positive x-axis and go counterclockwise. All right. Second rule is that the terminal arm, and we'll talk about what that is in a minute, terminal arm always starts at the origin and points outwards, and it always has a positive length. Okay, so let's take a look at what it looks like to represent an angle. So we're just going to choose, I'm going to choose 135 degrees. We're going to draw 135 degrees on our on a diagram here. Okay, so to do that, we're going to draw a Cartesian axis. We don't need any real labels right here. Just drawing basically across the center where the origin is. And we want to draw 135 degrees. So we'll start at the positive x-axis and go counterclockwise 135 degrees. So each coordinate or axis is separated by 90 degrees, right? And from one side of the x-axis to the other side is 180. So 135 is between the 90 and the 180, so it's somewhere around here. So this is 135 degrees, and then to represent that angle, we're going to draw a line, and that line is the terminal arm. So we start at the origin, and we draw it at that angle. A nice straight line as best we can. I'm going to draw it pretty big, because we're going to put some more labels on here in a minute. So that's 135 degrees. And that is us representing an angle on the Cartesian plane. Now we want to do more than that, though. We're going to, I'm going to extend a little line down here, down to the x-axis, and we're going to label another little angle right here. So this angle here between the terminal arm and the x-axis is called the reference angle, and we're going to define it right down here in a second. So this is the reference angle. Okay, so the reference angle is something we're going to use in a little bit. Okay, so this reference angle, so a reference angle is the acute angle. Acute just means an angle between 0 degrees and 90 degrees. Between the terminal arm and the x-axis. All right. So let's see how we can use these representations here to find the tan of 120 degrees. So here are the steps off to the side. And these steps are specifically laid out for solving this question and questions like this. But we're going to do a couple different things throughout the unit. And these steps are almost universal. There's some slight tweaks that will have to be made, but the process is very similar every time we do these kinds of questions. Okay, so the first thing we want to do is we want to sketch the angle on the plane. So I'm going to make a nice big diagram. We've got to write labels and stuff in these diagrams, so I would take up as much space as you can. Okay, so 120 degrees is going to be between somewhere around here. Okay, 120 degrees. Okay, so now we want to draw a right triangle to the x-axis. Okay, so that's something I did in that first example as well. So we're going to draw a line that forms a right angle with the x-axis here. So that's a right angle. So now we have a little triangle right here. And it's important we always form it to the x-axis. Okay, we could have, don't draw this part, we could have drawn it like this and we would have got a right angle triangle, but that's not what we want. This is to the y-axis. We always want it to the x-axis. Okay. Next thing we want to do is we want to find the reference angles. Remember, the reference angle is that angle between the terminal arm and the x-axis. So it's right here. So let's talk about how we can find this angle. There's a couple different approaches you can take, and it doesn't really matter which one you do. One thing we could do is we know that to go from the positive x-axis to the negative x-axis, that's 180 degrees. And 120 of it goes to the terminal arm, so there's got to be another 60 degrees between here. So we might say that the reference angle would be, 180 degrees minus 120 degrees, 60 degrees. That's one way to find it. Another way to find it is to go, well, I know that this is 90 degrees between the y-axis and the x-axis, and it's total 120, so this has to be 30 degrees up here. I'm going to erase that. It's really hard to read. And if this is a total of 90, then this must be 60 degrees as well. Okay? And I'm sure there's other ways you can come up with it as well. Okay, but the big point is that we have to find that angle. There's a couple different approaches we can take, and we find that it is 60 degrees. Okay, so the next thing we want to do is we want to label the sides using the reference angle to identify the special triangle. So let's stop at that step right there. So special triangles, well, this is a right angle triangle with a 60 degrees in it, right? So that's 60 degrees. This must be 30 degrees up here. That's definitely one of our special triangles. So you might want to sketch out the special triangle and label it ahead of time, or you can go look that up. But the side lengths are going to be 1 opposite our 30 degrees, root 3 opposite our 60 degrees, and 2 for our hypotenuse. Okay, so we aren't done this fourth step here. It says, and determine which sides are positive or negative. What does that mean? How can you have a negative side? All right, so because we're on the Cartesian plane, certain values are positive and negative. For example, over here on this half, x values are positive. So the horizontals are positive over here and negative over here. The y values or verticals are positive up here, but negative down here. So our terminal arm is always positive. That was one of the things we stated earlier. And this vertical here is in the positive y, so it stays positive. But our x value here is in the negative x's, so it's going to become negative. So we've labeled that now. So it's negative because horizontally, the x's are negative on the left side of our graph, of our Cartesian plane. Okay. So lastly, we need to solve using the reference angle to identify opposite, adjacent, and hypotenuse. So from our reference angle, we have opposite in root 3, adjacent, -1, and hypotenuse, 2. Now let's look at what we need. So we need tan. Tan of 120, so tan is SOHCAHTOA, opposite over adjacent. So in this case, tan 120 degrees. We use the reference angle to identify the opposite, adjacent, hypotenuse. So opposite, root 3 over -1. Root 3 over -1. And we can simplify that fraction a little bit. -1, we can just bring the negative to the top, get rid of the 1 on the bottom. It's going to be equal to negative root 3. All right. So this process, we're just going to repeat for each of these questions. So we're going to do a couple examples. So here's the second example. Sine of 225 degrees. Okay, so first we need to sketch where that is. So I'm going to draw a nice Cartesian plane, nice and big. 225. We just need a ballpark of where that is. We don't need to be perfectly exact. So that's going to be 90, 180. Here would be 270, so it's got to be in between. So let's draw it around. And something like that. 225 degrees. Okay. Now we want to draw our right angle triangle to the x-axis. It's right angle. We need to find our reference angle. So our reference angle here is going to be this angle. So we've got to think about how we're going to find that angle. So that angle is going to be, if that's 180 and that's 225, then this angle must be the difference. It must be 225 minus 180, which is 45 degrees. Hey, and 45 degrees, that's one of our special angles for a special triangle. So we can label our side lengths now. So you may recall that the side lengths will be 1, 1, square root of 2 for the hypotenuse. And we need to label which of these values are positive and which ones are negative. Okay, so our x, our horizontal value, is going to be negative in this quadrant. And our y is going down. The vertical piece is going down. So that's also negative. So both of these values are negative. Remember, the hypotenuse, always positive. Terminal arm, always positive. Only the other one's going to have negative values. So let's see. Sine 225. So sine is opposite over adjacent. Sorry, no, it's not. So opposite over hypotenuse. So sine 225 degrees is going to be opposite of our reference angle over hypotenuse. So negative 1 over root 2. And that's how we can find sine of 225. All right, we've got 2 more examples to do together. So the next one is secant of 300 degrees. Okay, so we're getting some big angles in now. So let's start by drawing our plane. I'm going to draw it off to the side so I got a bit more space. So 300 degrees. So 90, 180, 270. This would be a full 360 if we went all the way around. So it's somewhere in here. And we got our right angle triangle. I probably could have drawn this a little bigger. Might get a little crowded. That's why it's a good idea to draw nice big ones. So our reference angle between our terminal arm and the x-axis is here. We need to know what that is. So to do a full circle would be 360 degrees, and this was only 300, so we need another 60 degrees. So that must be our reference angle, 60. So now we can label our side lengths by our special triangle. So opposite our 60 is root 3. Opposite our 30 is 1. Our hypotenuse is 2. Next thing is we want to label what sides are positive or negative. Our x, our horizontal, we're on the right, so it's positive. Hypotenuse is always positive, but we're down, so our vertical is going to be negative. And now we're finding secant. So secant 300 degrees is going to be equal to 1 over, secant's the reciprocal of cosine. So 1 over cosine 300, which is going to be cosine is adjacent over hypotenuse. The reciprocal of that is hypotenuse over adjacent. So we need hypotenuse over adjacent. So it's going to be 2 over 1. So we could write that over here. Secant 300 degrees is hypotenuse over adjacent, so 2 over 1, or just 2. Okay, one last one. And this one has something a little special or extra to it. Cosine of 510 degrees. Now you may note 510 degrees, that's a really big angle. I think that's going to be hard to draw. So let's think about that for a second. I'm not going to draw it, but we're going to try to visualize it for a moment. So 510 would be 90, 180, 270, 360. Oh, it's hard after this. 450, somewhere in here. So we have to do like a whole circle and then some. Okay, we aren't going to do that because there's this idea of what are called coterminal angles. So coterminal angle are, that's poorly written. Coterminal angles are angles that give the same terminal arm. And if they give the same terminal arm, they must give the same trig ratios because our diagram would be identical. So to find a coterminal angle, we just add or subtract 360 degrees as many times as we want. Okay, so I just write plus minus 360 degrees. So in this case, coterminal angle for this, well, we can find that, we could say cos 510, that's going to be equal to cosine of 510 minus 360 is cosine of 150 degrees. If we take out our calculator, that's what we get. That is a lot easier to work with. I can work with 150 degrees, and we're going to get the same answer. So if I draw 150, hey look, I end up in that quadrant I thought I was going to end up in when I sketched out that 510. So let's draw this. So this is 150 degrees. So we need to find our reference angle here. So if that's 150 and this is a total of 180, there's a difference there of 30 degrees. Okay. And you'll notice my triangle doesn't really look like a 30, 60, 90 triangle, right? So when we're doing these sketches, our labels are the really important parts. Sometimes our diagram is inaccurate, like this one. Okay, but I know if I have my special triangle that opposite my 30 degrees is a 1, opposite my 60 degrees, which would be up here in my triangle, is a root 3. And my hypotenuse is always 2. Of course, I want to label my positives negatives. So over here, our x value is negative, our y value is positive, and our hypotenuse is always positive. So using the reference angle once again, cosine, that's adjacent over hypotenuse, which is going to be negative root 3 over 2. So we can finally write cosine of 510 degrees is equal to adjacent over hypotenuse, negative root 3 over 2. All right, so this is how we can find trig ratios and exact trig ratios for angles larger than fit in a triangle. We use the Cartesian plane to do such.